Yeah, today we'll be discussing how to solve equations with unknown on one side. Um, First of all, what is an equation? Equation is any relationship which involves this sign, which is equality sign, which shows two sides are equal, and it has a pronumeral in that, which we need to find the value of the pronumeral so that that equation is correct. For instance, if you consider this equation, this is 3k equal to 12. So remember, 3k means 3 times k. So what times 3 makes 12? It is 4. So the solution to this equation is 4, because only when k is 4, then these two sides are going to be equal. These are all examples of equations. 3p minus 1 equal to 5. So as we said, an equation has an equality sign and one side or both sides has a pronumeral like that. 2a plus 1 is equal to 3a minus 7. This is again another equation because we have this equality and we have pronumeral in this case on both sides. All right. There are things which we need to know how to solve an equation. There are two concepts. We are allowed to do the same operation on both sides of an equation. So when you look at this, this is an equation. This side is called the left-hand side. This side is called the right-hand side. So the equality sign is in the middle, and anything to the left of that is the left-hand side, and anything to the right of that is called the right-hand side. So what this first rule tells us, we can do anything we like to both sides of the equation, as long as you do it to both sides. So your answer is not going to change. Your solution is not going to change. For example, here I can add 1 to both sides. Or I can subtract 1 from both sides. I can divide both sides by any number I want. Or I can times both sides by any number I want without affecting my answer. So the answer still will be the same as it was for the original equation. All right. The second one, we need to know how to do inverse operation to go back to the pronumeral. So here you have 3k. What has happened to k? It has been times by 3. So you got 3k. So how do I go back to k? I got to do the inverse operation or reverse operation. 3 times k, so k has been times by 3. The opposite of timesing is dividing, so I need to divide by 3 to go back to k. But as we said, based on the first rule, if I'm dividing this by 3, so that I go back to k, I got to do the same to 12. I got to divide 12 also by 3. All right, here we've got an example. Assume you have number 3. You multiply it by 2. So 3 times 2 becomes 6. And then you add 1, you get 7. Now how do I go back from 7 back to 3? All right, how do I go back to my original number, which was 3? I've written this in the form of notations here using arrows. So 3, you times it by 2. So it becomes 3 times 2. Then you add 1. So that becomes 6 plus 1, 7. All right, we are interested in going backwards. I want to go from 7 back to my 3. So I got to do the opposite operation. And I got to undo the last operation first. So when I'm going back, the last operation that we did, we added 1. So I got to take away 1. So the opposite of adding 1 is taking away 1. So 7 take away 1 is 6. Now here the operation that we've done, we times by 2. We're going to do the opposite of that. So we're going to divide by 2. So 6 divided by 2 is 3. And I went back to my 3. That is important to understand. Let's do the same with a pronumeral. So you have k, you times it by 6. You get 6k. Then you add 2. You get 6k plus 2. Now I want to see how can I go back from 6k plus 2 back to k itself. So I start with 6k plus 2 and I do the opposite operation. Here I'm adding 2, I got to take away 2. So if I take away 2, I'm going to end up with this, which is 6k. You can think of it like that, or you can say, okay, 6k plus 2, take away 2. So I added 2 and I'm taking away that 2. So this 2 is gone, I end up only with 6k. That is one thing. Then here we times it by 6. The opposite of timesing by 6 is dividing by 6. So 6k divided by 6 will get me back to where I was, k. Or again, you can see it here, 6k is 6 times k. If I want to go back to k, I need to divide by 6. Alright, here in example 1, they are saying by doing inverse operation, go from 7u minus 6 to u. Alright, before doing that, I got to start with u. Alright, I got to see, to inform myself what should I do to go from 7u minus 6 to u. I first look at what has happened to u, so it has become 7u minus 6. So the first operation that has happened to that is we times it by 7. So that gives us 7u. Then we take away 6, so we end up with 7u minus 6. Now I know what has happened to u to become 7u minus 6. I can see how I can go back. So I need to add 6 because I got to do the opposite of that. Then I need to divide by 7. Do the opposite of that. So 7u minus 6, as you can see here, minus 6, I had plus 6. So that will take me back to 7u. And then from 7u to go back to u, on the way at the start, I times it by 7. Now I need to divide by 7. Okay, so you can also do this operation without actually looking at that. Here you can say 7u minus 6. I want to get rid of this minus 6. So to get rid of subtracting 6, add 6. So that minus 6 plus 6. They go away, you end up with 7u. Now I've times 7 by u. I want to get rid of this 7, but 7 has been timed. So I got to divide by 7 to end up with u. Okay, now we know how to do that. Let's use it to solve an equation. Here I've got 7u minus 6, the same thing that we had, 7u minus 6. When solving an equation, you got to do these operations, so you end up with u on your left-hand side. Alright, so write the equation the way it is, 7u minus 6 equal to 8. What I've done here, I added 6, so I'm adding 6 to that. See, the aim of adding this 6 is to get rid of this takeaway 6. But if I'm adding 6 to this side, as we said, we got to add it to the other side as well. All right, 8 plus 6 is going to be 14. Then I have equality here. And then this minus 6 and plus 6, they're going to cancel out. So I get 7u. Or you can see it here that I've got 7u. All right, 7u is equal to 14. What has happened to u has been times by 7. So I got to do the inverse operation, which is also here. 7u divide by 7, so you get to u. So divide by 7. I want to get back to u. But if I'm dividing this side by 7, I got to do the same with the other side. So then 7u divided by 7 gives me u, and 14 divided by 7 gives me 2. That is my solution. So u must be 2. So that means if u is 2, then this equation is going to work. This side of left-hand side of that is going to be equal to the right-hand side. Because if u is 2, that's going to be 7 times 2, which is 14. Take away 6, which is 8. So as you can see, it is working. So that is the procedure for checking your answer. You replace u with 2 and see what you get. If you get what is on your right hand side, then your answer was right. Otherwise, you made a mistake. All right, another equation, 3p plus 5 equal to 12. Okay, again, I got to think what do I need to do here? What steps I need to take here to go back to just p? All right, the first thing is I got to undo this plus 5. So I got to take away 5. But if I'm taking away 5 from my left-hand side, do the same on the right-hand side. Take away 5 from that too. All right, so if plus 5 and take away 5, these two are going to cancel each other, so nothing will happen. So it was just 3p. So we had 3p, I added 5, now I'm taking away 5. So I end up with 3p again. And then 12 take away 5 is 7, and the equation stays. So 12 take away 5 is 7. All right, now I got to think, how can I go back to p from this? So what has happened to p? It has been times by 3. Then I got to divide by 3. If I divide by 3, I go back to p. So I'm dividing both sides by 3. So I go back to p on this side. And on the other side, because I had 7, then I basically, I'll show it here. Because I had 7, I'm going to divide 7 by 3. But 3 doesn't go into 7, just write it as a fraction, 7 over 3. Yeah, that is how you solve equations on with pronumeral on one side. Say if this was minus 5, then I needed to do plus 5 here. I needed to do the inverse operation so I can get rid of minus 5. If this was minus, I needed to add 5 to this side. But if I'm adding 5 to this side, I would have added 5 to this side as well. Okay, thank you for your attention.